Hello, am I audible? If you can see my screen and can hear me, kindly let me know. Then I will go ahead, okay? We hope I can make myself audible to you. Yes, I want to hear from you. Can you hear me? Or you can just write in the chat box also if you cannot be unmuted or some technical difficulties. So if my screen is visible and if you can hear me, kindly let me know. So I can hear none of you. So shall I go ahead? Can I get a confirmation from your end? Because I cannot understand whether you can see my screens or not.
Yes, sir. Proceed.
Okay, so I can go ahead, right? And you can see the screen also. So welcome to the week 5 of the NPTEL course electrical measurements and electronic instruments, and I will be your TA for this session. So any doubts from the previous weeks, you can let me know. Any doubts in the previous sessions or the previous weeks or this current week, or any doubts you face while solving the problems, you can just let me know. And we can have a discussion, one-to-one discussion on that, such that I can clear your doubts. Or any concepts you want me to repeat or you are facing difficulty to understand, you can let me know. So I want to hear from you, because please feel comfortable to let me know your doubts, because these sessions are meant to be interactive and you should be interacting with me to get your doubts clarified. So kindly feel free to unmute, or also you can turn on your videos and we can have a one-to-one discussion regarding any doubts you faced in these weeks or the sessions. So any doubts? Any doubts or any concepts you want me to repeat? Kindly let me know. Okay. Yes. Any doubts? Please feel free. Okay. If you don't understand anything, kindly let me know. Yes. None of you are responding. So any doubt, you can let me know.
No doubt, sir.
If any one of you has any doubt, just feel free to let me know. Okay, then we can jump into the problems. But first, if you clarify your doubts, okay? So if any doubt, you can just let me know. So no doubts, right? So then we can jump on to the problems on the AC bridge networks, which is of the current week 5, right? So we can solve the various types of problems. And the first problem, I hope you can see on your screen, that which of the following bridges, and obviously these are AC bridges, and they are asking you that which of the following bridges can never be balanced. Okay, and you can assume that all the components that are shown on the screen, that is in all the options, the elements are ideal in nature. That is, if they show you L, that means it is L, not any or R with maybe capacitor with ESR. If it is having an ESR or having a resistance with it, it is shown in the screen. So additionally, you don't need to assume any non-idealities inside the components. So you can assume the non-idealities to be 0. So for capacitor, actually we show it with a small resistance, ESR, which we tell ESR, okay. And obviously with an inductor we have a series resistance. So maybe we can write it as RS, LS and CP, RP. Now if this capacitor is very good, AC capacitor obviously I'm telling, then this resistance part should be small or large? Any one of you? Yes, I want to hear an answer. For the capacitor to be very good or for the inductor to be very good, what should be the values of RS and RP? High or low? Yes.
Low, sir.
For inductor or capacitor?
For inductor, sir.
Correct. So if it is an inductor and you model it as a series resistance in series with that inductor, obviously it should be low to improve the quality of this inductor. We also denote it with quality factor.
Yes,
so
sir.
How high may be the quality factor, better is their inductor design, because it will incur lower losses due to lower value of this series resistance which you have modeled. But in the capacitor, you should have low ESR or high ESR?
High, sir.
No, ESR. ESR should be low. What is the full form of ESR? Yes? Any one of you? Any idea?
No, sir.
Equivalent series resistance, right? So in the capacitor, if you model it as a series resistance, then it should be low, agree. But I showed it as a parallel resistance. So this parallel resistance should be high enough, because the current entering through this resistance should be low, such that you incur minimum amount of loss. And from that, the idea of loss angle delta came, right? In capacitor, we don't use the term quality factor, we use the term dissipation factor. And dissipation factor is nothing but tan of delta. So where you see na, this angle, theta, and this will be R, this will be C. omega 1 by omega c, right? The impedance, or you can say the reactance offered by the capacitor will be in the base, and this will be the dissipative part, that is the R. So how much more be the dissipative part of the capacitor, then your theta will keep on increasing, or delta. So this is the triangle that we draw for the dissipation triangle, we can like that we can turn. But for the inductor, your reactance will go up and R will go down, because you have modeled it like that, and that theta will be known as the quality angle. So how much more this angle be, better is your quality. So in quality factor Q, we write it as tan of theta, which is omega L by R. But in dissipation factor, what will you write? Tan of delta?
R by W.
Yes, but this angle is the what? Will become omega R C, right? But if someone asks you what is the quality, then it will be 1 by D, right? Because that is the quality, and this is, we are talking about the dissipation. So more is the D, more is the dissipation, more lossy is your capacitor. However, if you want to find out the quality, it will be just 1 by D, because it tells you how much good the capacitor is. So goodness is equivalent to or congruent to 1 by badness, as we might have seen in the lectures also, right? So please don't confuse
Yes.
with quality factor and dissipation factor, right? So that is what I wanted to just have a brief discussion with you, so that you don't confuse with all these terminologies. And it is also important how you model the capacitor, non-ideal capacitor and non-ideal inductor. So generally, if you see in the practical areas, we model it using, since the inductor, you flow the current through the inductor, we model the non-ideality using a series resistance. However, since the voltage is applied across the capacitor, you model it using a parallel, another shunt resistance, I can tell, and that is the non-ideality, to include the non-ideality. However, the measure of how much non-ideal the capacitor is, or how much lossy the capacitor is used by the factor, denoted by the factor D, dissipation factor, and this you call the loss angle. Okay, don't confuse. Okay. However, this angle is not the loss angle for the inductor, right? Because you have the omega L in the height. So tan theta will then give you the quality factor. So now solve this problem. So what will be the possible options or possible combinations where you can never get a balance? Obviously, one information we need to give you, that these are the 2 points for all the cases where you have applied the source and the meter is connected here. This is very important option, very important information, because if you reverse the nodes, then the balance condition will be different. For example, if this is Z1, if this is Z2, this total impedance maybe, and if this is Z3 and this is Z4, then what I can write? Z1 by Z2 equal to Z3 by Z4. But if I would have applied the voltage like in these 2 nodes, then it would have been this by this, right? Equal to this by this. However, since I applied in these 2 nodes, the balance condition will be this by this equal to this by this. Or you can write in product form as Z1, Z4 equal to Z2, Z3. So that means that its product of the amplitudes will be like this, Z2, Z3, and your sum of the angles should be equal. That is in polar form. If we equate both sides, we will get the same thing. So what are the possible options? I will make the screen clear for you, or maybe I can again copy this or duplicate this slide and remove these things. So just see which of the following options you are getting a balance, or it is possible to get a balance. But it is asked which of the following bridges can never be balanced. So only tell me which of the following combinations can never be balanced among these options: A, B, C, D, E, and F. You have 6 different bridge configurations, and tell me which of the bridges can never be balanced if the excitation is given at these 2 nodes. Tell me. Yes? Anyone? So kindly solve this problem and let me know, okay? You should be solving with me, okay?
Okay, sir. Done? So what are the possibilities? I told you na, that this by this should be equal to this by this. So here you have a capacitance, you have an inductance variable, and these 2 parts are real. So when you divide these 2 to get the balance, is it possible to get a balance here? Because C will have an angle of, maybe XC will have an angle of minus 90 degree, right? And your L will have some plus J part. So when you divide it with XL with some plus J part, it will become, yes, I want to hear an answer from you. Yes, sir.
Yes, so what will be the options? Kindly tell me. So you can assume this as Z1, and you can assume it as Z2, assume this as Z3, this as Z4. So what I am telling is Z1 by Z2 should be equal to Z3 by Z4. Now, if you write like this, Z1 into Z4 equal to Z2 into Z3. Now, what is Z1 into Z4? It is some capacitor multiplied by some resistive, right? So, what is the angle? Angle will be always minus 90 degree, right? Because when you multiply, you add the angles, right? So, 0 plus minus 90, right? And it is what? Z2, Z3? It is plus 90
plus 0. So can this be equal? No, right?
No, sir.
So you will never get a balance for case A. Now check the other cases. Check this one, second one, then third one, check and let me know.
Okay, sir.
Same, you do Z1, Z2, Z3, Z4 and then you check the angles. Do it.
सेकेंड वाला हो सकता है सर.
कौन सा वाला?
सेकेंड वाला मतलब सी.
Okay.
सी नंबर.
So how it will happen?
एंगल 0 हो जाएगा सर दोनों का. एक्सी एंड एक्सएल का.
0 कैसे होगा? 0 नहीं होगा. ये अगर आपका Z1 है, ये Z2 है, ये Z3 है, ये Z4 है, तो आपका Z1 इंटू Z4 इक्वल टू Z2 इंटू Z3. Z1 इंटू Z4 क्या होता है? -90 प्लस -90 एंड Z2 प्लस Z3 क्या होता है? 0 प्लस 0. तो आपका -180 इज नॉट इक्वल टू 0 डिग्री ना. तो कैसे
सी नंबर को
सी
सी. यस सर.
ये भी नहीं होगा मतलब. ठीक है, दिस विल आल्सो बी नॉट बैलेंस्ड. सो ए और बी नॉट बैलेंस्ड. तो सी कैन बी बैलेंस्ड, राइट? बिकॉज these two can cancel, right?
बारे में बोल रहे थे सर.
हाँ, तो सी आपका हो सकता है, बैलेंस हो सकता है. तो फिर डी देखिए. फिर डी देखिए. सेम है ना. ये कैपेसिटर और एक रेजिस्टिव है, तो -90 का पार्ट आ रहा है, लेकिन यहाँ +90 का पार्ट आ रहा है, तो डी भी बैलेंस नहीं होगा. ठीक है, बट ऑल अदर ऑप्शंस
नहीं होगा सर. ठीक.
these two and these two can be balanced. Similarly, these two and these two can be balanced. तो आपका ए या बी और डी बैलेंस नहीं हो सकता कभी भी. ओके, so this was the just explanation. So see the next problem. I hope the next problem is visible on your screen.
Yes sir.
Two sets of problem are there, two different subsections. So try it. So assume a bridge, general bridge like this. Okay. और आपने इसको अगर Z1, Z2, Z3, Z4 बोले हैं, the excitation you give always here, and the meter is connected like this. Now maybe this is L1 R1 like it is mentioned ना. L2 R2 आप यहाँ मान लीजिए सीरीज में, और R3 और R4 यहाँ मान लीजिए. ठीक है, आपको पूछा जा रहा है, is it always possible to get a balanced condition only by varying the frequency? तो आप अगर सप्लाई का फ्रीक्वेंसी को ही वेरी करके जाते हैं तो कैन यू गेट बैलेंस? काइंडली थिंक अबाउट इट. और अगर आपने ये पार्ट आंसर कर दिया तो नेक्स्ट पार्ट पूछ रहा है सप्लाई वेवफॉर्म के बारे में. सप्लाई वेवफॉर्म, हाउ शुड द सप्लाई वेवफॉर्म बी टू गेट द बैलेंस कंडीशन? कैन इट बी एनी periodic function or can it be any one of these? So you need to comment about the supply waveform nature and the frequency for the condition of balance. So kindly see. Note that these magnitudes are all fixed, right? This is given fixed. तो आप जो भी कर सकते हैं वैरी सप्लाई में ही कर सकते हैं. या तो सप्लाई का वेवफॉर्म बदल दीजिए, या सप्लाई का हार्मोनिक इंजेक्शन करिए, या फिर डिफरेंट फ्रीक्वेंसीज में, और या फिर यू कैन चेंज द फ्रीक्वेंसी ऑफ सप्लाई ऑल्सो. So in that case, can you obtain balance condition?
हो सकता है सर.
कौन से
क्योंकि
केस में हो सकता है? बैलेंस कंडीशन क्या है? व्हाट इज द कंडीशन ऑफ बैलेंस? Z1 by Z2 इक्वल टू
yes, sir.
Z3 by Z4। इसका मतलब ये होता है कि Z1 Z4 इक्वल टू Z2 Z3 implies that you have two conditions, Z1 Z2 Z1 Z4 equal to Z2 Z3 and theta 1 plus theta 4 क्योंकि प्रोडक्ट है theta 2 plus
Yes.
theta 3। तो आपका पास दो कंडीशन है, ठीक है। आपको मैग्नीट्यूड को भी सेटिस्फाई कराना पड़ेगा, दिस वन, एंड यू हैव टू सेटिस्फाई द एंगल आल्सो, राइट?
Right, sir.
But when you change the frequency, then Z1, Z4, Z2, Z3 all will vary
Yes.
because you are changing the frequency. However, the phases will also vary.
Yes, sir.
So if you vary the frequency only, then all the parameters, including the magnitude and phase, will vary. This part is understood. So for only variation of the frequency and if the impedances are constant, and
सर इसमें
हाँ बोलिए,
बोल रहे हैं कि जैसे एल पार्ट ही चेंज होगा ना सर, आर तो वेरी नहीं करेगा एंगल उसका।
नहीं मतलब मैग्नीट्यूड पार्ट जो है आपका, क्योंकि क्यू एंगल नहीं वेरी क्यों करेगा? व्हाट इज एंगल? व्हाट इज थीटा 1? ओमेगा 1 L by R। तो आपका ओमेगा तो वेरी हो रहा है तो थीटा भी चेंज होगा।
अच्छा ठीक ठीक।
और वो नॉन लीनियरली चेंज होगा, पता है? tan इनवर्स ओमेगा L by R होगा ना।
यस सर।
लीनियर नहीं रहेगा। तो by changing frequency, what I mean to say, Z1 Z4 will vary, Z2 Z3 will vary, and also your theta 1 theta 4 theta 2 theta 3 all will vary. Now assuming at the starting it was unbalanced, then for no frequency you can get balance by only varying frequency. Correct?
Yes sir.
Because at the starting it was unbalanced. And when you go on changing the frequency, both of the sides will vary. So always it is not possible to get the balance. Maybe at some specifically designed frequency, it can be balanced, but not for all. It is not always possible. So since it is telling always possible, it is wrong. Because you can see now all the parameters are varying. How can we guarantee that it will always be balanced when the values are fixed? Then answer the next part. So previous question you understood, right? So
Yes
I
sir.
can write, since with omega both magnitude and phase of the impedances vary, it is always not possible to guarantee balance, right? So this is the part one. Okay, so I want to know that Okay, I understood that varying the frequency will not always ensure balance. But can I know about the waveform, the shape of this signal for which it will be balanced? So do you have a constraint on that also? Just answer that.
Not constant, sir.
Oh yes, what is the option?
Any periodic function.
How are you saying any periodic function? What is the logic? What is the logic of the bridge balance? Can you justify? Yes. Yes, kindly be interactive. Otherwise, you will not understand. I can just tell you the solutions, but that will not help, right?
Yes, sir.
So try what is the reason and which option can be the logical possibility actually. So you think sometime and then answer. Kindly try, okay? Any idea? You can
No,
just
sir.
discuss. No, what are you thinking? Can you just elaborate your philosophy? Then we can have a discussion. But how can the nature of waveform have an impact on the balance condition? How is it linked? It is linked by, can you tell me? Because in the balance condition, nowhere can you see the strength of the AC signal that is being applied. or is it there?
Yes.
These are all impedances, right?
Yes.
So where is the participation of the source? Can you tell me? Who is governing this balance condition? Is it governed by the strength of the source?
Impedance, sir.
No, impedance, okay, but what is the role of the source, I am asking, in that impedance? The strength of the source or the frequency of the source? For example, I am applying V sin omega t. So who is deciding the balance condition? This omega, right?
Yes, sir.
V has no participation. So for example, if I take any other signal, for example, square signal, how can I break it? Yeah, I can write as V1 sin omega 1 t plus V3 sin omega 1 t, okay? But this will be 3 omega t. So the frequency and strength of the signal is different. So for one fundamental frequency, you have a different balance condition for first. Then for 3 omega, you have another balance condition. So for 5 omega, you have another balance condition, which will not be possible to balance for all one frequency. So for no frequency, the square wave can be balanced. Similarly, for no frequency, because all the condition will be different. For first fundamental balance, it will be a different condition. Then for 3 omega balance, it will be a different condition. So all condition cannot be always satisfied one at a time for a given frequency. I am telling. It cannot be always balanced. For a special case, it can be, but for one particular frequency, if the nature of the signal changes, then you have different harmonics also. So you need to take different balance conditions, and all cannot be satisfied all at the same time. But if it is sinusoidal, then it has only one frequency. And for one frequency, you can vary the one of the parameters. Or if you are not allowed to vary, then you can set that omega. You can determine omega for which the bridge will be balanced, right? From here. Since Z1, Z2, Z3, Z4 cannot be changed in magnitude, you can determine the angle. And from the angle, you can get the frequency, right? I hope you can understand what I am telling, right? Or not? So for that frequency, if you inject, then even for fixed magnitude, fixed strength of these impedances, you can get a balance condition only for sinusoidal. Okay. So do you want me to repeat, or this is clear?
Repeat, sir, once again, sir.
So what I'm telling, if you have a non-sinusoidal signal, then you can
Yes,
break
sir.
it down into harmonics. And for each
Yes,
of the fundamental 3 omega, 5 omega, you have different balance conditions. But since the
right,
values
sir.
of the parameters are fixed, it will be balanced only for one particular condition, one particular frequency.
Yes, sir.
But you are injecting different frequencies through the supply. So how can the bridge be balanced? It will be balanced for one particular frequency, not for all frequencies. Even if you inject different frequencies, it will not be balanced. If you inject different frequency of sine also, it will not be balanced. Only for one particular frequency, since the values are fixed, there is one particular frequency which you need to determine from this angle and amplitude. Correct? So then only it will be balanced. However, since you are injecting harmonic frequencies, then it will not be balanced for all the frequencies. For one particular case, it only is balanced, and that you need to determine. So only for the sinusoidal signal, which is having one frequency, you can get a balance condition. That's nature of the signal I am telling. Other signals are having different harmonic frequencies. So for different harmonic frequencies, you will get different balance condition, and all are not possible to satisfy all at the same time. That is why you cannot ensure a balance condition in those cases. I hope I am clear, or you need more explanation?
Yes, sir. Clear, sir.
Okay, so just solve the next problem. Okay, just try. It is a basic shading bridge where you have given 4 impedance and the 3 are known, and one of these is to be determined. One of the impedances are to be determined. And the supply is shown here as I showed you. So you can write the balance condition and derive the values of Rx and Cx. So just determine. Also you let me know value of Rx, okay? Solve it. So take time and solve, okay? If you have faced any difficulty, let me know. Anybody solve it? It is easy, right? Compare the imaginary and real parts and then let me know, okay? Yes, so please solve this problem, okay? Try this problem. This is the first balance problem, so you need to solve yourself, okay? I want to hear the answer from all of you. So it is a simple problem, okay? Just write the balance condition. Maybe you can assume this as Z1, this as Z2, these are Z3, these are Z4. And what will be the balance condition? One of you tell me. Excitation is given at these two nodes, okay? Kindly note, don't confuse. Then I can write Z1 by Z2 equal to Z3 by Z4. Then I can write what? Z1, Z4 equal to Z2, Z3. Now I separate the phase and amplitude, or you can do it in the Cartesian form also. So I can write two conditions. And another condition is that theta 1 plus theta 4 will be equal to theta 2 plus theta 3. Or without doing all this, you can just simply write Z1 by Z2 equal to Z3 by Z4 and plug in the real, that is actual impedance value in the form of whatever you have these parameters. And you can just equate the real and imaginary parts in the Cartesian form also. So maybe I will suggest doing the Cartesian form. It will be easier, okay, to compare. And compare real and imaginary parts, right? For both sides of balance equation, right? So write it down and then break it into real and imaginary parts and compare the both sides. They will be equal, right? Real is equal to real on left side is equal to real on right side, and the imaginary part on the left side will be equal to imaginary part on the right side. So from that you can determine, since C1, C2, R2 and R3 are known, what means is that you know already Z3 because R2 and C2 are known, and you already know Z1 since C1 is given, and you already know C2. So C1, C2, R2 and R3. So R3 is in Z4 is also known, right? So you only need to determine this Z2, which is easy. Because to determine Z2, you need to know its real and imaginary parts, which you can derive from this or this. And you will get the real and imaginary parts, right? So solve it yourself, okay? Kindly let me know. I will give you time and then we'll proceed. Because in this problem, you need to give some time. First time you need to solve and then check. And let me know the answer in terms of what is the value of Cx and what is the value of Rx. So tell me both the answers, okay? Anybody has done? It should not take much time, right? So write all the impedances in the impedance form, right? All the elements in the impedance form you convert. Okay, so this should be minus j by omega c1. Similarly, this you should write in the impedance form, which is R2 parallel minus j by omega c2. So for Z3 it is. For Z1 it is minus j by omega c1. Then for Z2 you can write as Rx minus j by omega cx. And then for Z4 you can write R3. Now you can equate Z1 Z4 equal to Z2 Z3. So you can write what? Z1 is omega c1, right? And multiplied by Z4. Z4 is R3 equal to Z2 into Z3, right? So what you will do to get the balance condition? Yes? Any idea? What is the parallel combination of R2 and C2? Just check. R2 into minus J by omega C2 divided by R2 minus J by omega C2, right? And if you resolve it, what will you get? So you want the balance condition, right? None of you are solving, it seems.
We are trying, sir.
Yes, so just resolve, okay? You can take this in that side and then compare the real and imaginary parts. So I can write it for you. It is minus J, or I can take this there. So what I can do is, so what you get when you resolve? You get minus J omega minus J R3 you are getting by omega C1 multiplied by R2 minus J by omega C2. This should be equal to Rx minus J divided by omega Cx. And you have minus JR2 by omega C2. So if I write it in the simplified form, I get minus J R2 R3 by omega C1 plus J square means minus 1. So I have a minus R3 divided by omega square C1 C2. And if you do the same thing on the right side, you get minus J R2 Rx by omega C2 and plus, then you have J square which is minus, and you get R2 by omega square C2 Cx. So you compare this, and you compare this with this. What you get? R2 R3 by omega C1 equal to R2 Rx by omega C2. This is one condition. and then you get R2 by Cx, just C. Omega square and C2 will get cancelled, right, on both sides, equal to R3 by C1. Is it correct? So Cx
Yes,
can
sir.
be determined as R2 C1 by R3, which is required, and Rx can be determined as what? R3 C2 by C1, right? So see these two equations. So was it that difficult to solve? So why you are not able to solve? Now try Rx and Cx, you try values. Values are given in the question. That C1 is 1 microfarad, C2 is 900 nanofarad, or you can write it as 0.9 microfarad, right? Then R2 is given as 170 ohms and R3 is 400 ohms. Using these, you calculate the value of Rx and Cx. Let me know, okay? Yes, what happened? You should not take more time, right? You have the formula. Kindly let me know what is the value coming. Cx and Rx.
Cx equal to 0.4 microfarad.
Okay. So since C1 and Cx are both in micro, so since
Yes,
C1
sir.
is micro, Cx can also be told in micro. Since R2 by R3 is what? 170 by 400 you do, then multiply by 1. So what is 170 by 400? Is the value of Cx in microfarad. So what is R2 by R3? Please let me know. 170 by 400, what is it? 17 by 40 is, you do it, what you get, you do. It is 0.42, right? And then Rx is C2 by C1 is micro gets cancelled, and then you get 0.9 times R3. So 0.9 times 400 ohms, which is nothing but what?
360.
So you can just calculate in this way for any bridges, right?
Yes, sir.
So now you see this problem. This is asking you what is the value of Rx, right? So 3 is 360 ohms. So you see this next problem. It is asking you to calculate the dissipation factor of the unknown capacitor. I told you just few minutes before how to calculate dissipation factor. So you draw the triangle. Just try yourself, then I will let you know. First you try, okay? If you don't try, it will not help you, okay? If I tell the solution, you will forget today only. You should do everything with your logic. And if the logic is clear, you will never forget, right? So you try yourself. Anyone done? You're taking a lot of time. It should not take that much time, right? So how you are doing? Can any one of you tell me? You can discuss, okay, how you try to solve, and then you can just go ahead with the solution. So how will you solve? Any idea? So I told you na how to calculate the dissipation factor. It is nothing but an estimate of how lossy is your capacitor, right? So it is asking you to calculate actually how lossy is your this capacitor. Okay. So you will draw the triangle, right? The dissipation part and the reactive part. And the angle will determine that, for example, if this is the delta, the loss angle, then this should be the dissipative part. And this should be the reactive part. Okay. And you know the dissipative part is Rx. So always bring the capacitor to the series RC form, right? To calculate the dissipation factor. This should be 1 by omega Cx. So tan delta is nothing but Rx Cx into omega. So your tan delta is nothing but the dissipation factor. So this was that much simple. So what will you do? Omega is given. So always bring to series RC form, right? Then you get the tan of the dissipative part divided by the reactive part. So now calculate what is it. Now it should not be a problem, right? So what you are getting answer of D? Yes, it should be easy now, right? What is Rx? 360 ohms. What is Cx? 0.4 microfarads. 0.4 or what we got? 0.42, right? So now calculate. Yes.
0.
What is coming?
0.05. 0.054.
Okay, let me calculate. No, do it correctly. It is 0. I am getting 5. Okay, 0.05, yes. 0.057, correct? Yes, yes. So now you solve the next question.
सर इसमें जो सीरीज में रहेगा उसी से मतलब डिसिपेशन फैक्टर निकलेगा क्या?
हाँ, क्योंकि डिसिपेशन होता किस लिए? करंट के लिए है, तो आई स्क्वायर आर होता है ना। तो आपका डिसिपेशन कैसे निकालेंगे? इट इज आई स्क्वायर आर बाई, और रिएक्टिव पावर क्या होता है? आई स्क्वायर इंटू जेड, और सॉरी आई स्क्वायर इंटू एक्स, उससे तो आएगा ना। वोल्टेज से होगा तो उल्टा हो जाएगा।
ठीक,
इसको ट्राई कीजिए एक बार, दिस प्रॉब्लम। So basically what they are asking, can anyone tell? Yes, anyone? What are they asking to calculate in this question? Kindly let me know what is asked in this question. What do you understand? So they are asking you to calculate the voltage across the variable branch. So this is the across this element. They are asking you to calculate the voltage. You need to read and understand, okay, what they are asking. So calculate the voltage across this branch. If this is 4 kV, and all the element values are given, right? And Rx and Cx you already know to be 0.42 microfarad, and Rx you know it is 360 ohms. So now calculate what is V, where V supply is given as 4 kV. Calculate. Yes, you should try, okay, this problem. Please try. How will you do? At balance. Please note it is asked at balance, okay? So at balance, how will you do? Any idea? Or you guys are not trying? See, these sessions are meant to be interactive and for you to solve the problems.
Yes,
If
sir.
if you don't do the practice, it will not help you. I can just write the solution, so it will be of no help. You need to understand what is being asked in the question, discuss with me, and then proceed with the solution. Then only I will give you the solution, right? You need to discuss what you are thinking and how will you solve. What are the steps you will follow? Yes.
बैलेंस कंडीशन में सर दोनों ब्रांच में C1 और आपका R2 पैरेलल C2 में 4 kV होगा voltage.
Because no current is flowing, so this
Yes,
branch can be decoupled from the rest of the circuit. You can just open it. Then
Yes.
what will you do? You will apply voltage division rule. And you always know R3 is this much for the balance condition. So what is V? It is nothing but, how can I write? 4 into 10 to the power 3 is getting divided among, so current times this current means the total voltage. So 360 square plus 0.42 into 10 to the power minus 6. This is C multiplied by omega. So omega C. So 1 by omega C you do, and then square. Okay. And then whole root over. This is the impedance magnitude, and then you get plus R3. So this is 400. And this R3 is also 400. So what I did V by total Z across this path. Obviously, the magnitude of the Z times the Z or the resistance across that node to find the voltage across that node, right? So the net resistance is this 360 square plus 1 by j omega c, 1 by omega c square. So omega and c whole square, whole root over, you get that magnitude of Z and plus with t. So tell me what is the value coming? Obviously, this is mod of V, right? So what is the value coming? Tell me. Yes? Solve what is the value coming, you should be able to solve, right? None of you guys are paying attention, right? So is it written correctly?
इक्कीस 2105 सर.
Yes.
2105.26.
No, but that is not the correct answer because you are not paying attention, right? Because this what I have written, r square plus 1 by c, 1 by omega c whole square whole root over will give you the impedance of this branch. Now I cannot add impedance of this branch with the r. What I need to do? 1 by r net whole square plus 1 by omega c whole square whole root over. But this is not r net. This is only this r. You cannot add the total impedance with the other resistance. What you need to do? So this is wrong. You should have told me. So what you need to do? V
Yes,
is,
sir.
so you tell whatever I am writing why you are blindly, but that means you are not solving. You are just seeing on the screen and then writing down the solution. That you should not do, okay? You should try and solve. Otherwise, same mistakes you will make in the exam, right? So what is the voltage? You tell me again. 4 into 10 to the power 3 is the total voltage across this branch.
Yes, sir.
I want to divide this voltage across this path.
Yes, yes,
Across
yes,
the
sir.
R3. So what I should do? I should divide it by the total impedance of the path. Total impedance, how will I get? Magnitude. Total impedance magnitude. R net and then the reactive part net. Whole square it and then root over. So what is R net? R net is Rx plus R3. Rx plus R3 means 360 plus 400 ohms. So that means what? 760 ohms. So that is the net resistive part. And then you add it with your reactive part. Reactive part only you are having C here. So 1 by omega C. C is 0.4 into 10 to the power minus 6 whole square. Then whole root over. Multiplied by the impedance across which you want to calculate the voltage drop. So that should be 400. So calculate. Now let me know what is that. So this is wrong, right? This is wrong. So why wrong? Take net R and net X. And then Z is root over R net square plus X net square. So reactance and resistance. Net resistance and net reactance whole square is the Z. So in this problem, you could have made this mistake. That's why I told you, right? Now you should need to calculate this. What is the net Z? You tell me. You solve and tell me, okay? These types of calculation you should be able to solve on your own. Otherwise, for small silly mistakes, you can get wrong answers. And then your marks will be deducted, right? And also be sure what is the given frequency, 60 hertz or 50 hertz. For that also your values will change. So be careful about all the values and what you are calculating. So net impedance, you divide the voltage and then you multiply it with the resistance across which you want to calculate the voltage. So now let me know what is the voltage magnitude. Now you should be able to do, right, on yourself. So what you are getting, you tell me. Yes. Any idea? Or you are not solving? Yeah, simple calculation, right? Just you need to plug in the values and let me know what is the voltage coming. So are you guys trying?
Yes, sir.
Yes, so please just try and solve this problem. So please note there is a root, square root. Don't forget. Many times you may also forget the root and then the answers will be different, right? So I will just remove it and write it clearly for you. So now this is 1 by 2 pi 60 times your 0.42 is the capacitance and you get the net reactance. So that whole square and then whole root over, right? Whole root over this. And then you can get voltage and then you get the current and then you multiply it with the element across which you want to get the voltage drop. That is the basic concept, but only was the calculation of the impedance that would have made the mistake. So what is the value coming, you tell me? So what is mod V coming, you tell me, in volts? Yes, the magnitude of V, obviously we are calculating, not the angle. So all the magnitudes of the impedances we are taking, not the polar calculation we are doing here. So what is the answer, you tell me? Unless you solve, you will not be able to do. Full problem you need to solve by your own. These kind of problems are important, right? Yes. So what you are getting? Also, don't forget to convert kilo ohm to ohm. Okay. And maybe nanofarad to microfarad, and all those should be taken in farad. Simple. Because the calculation of voltage when you are doing or impedance, all should be taken in the units, the standard units, ohms, farads, and all those things. All the powers you need to do accordingly. So what is it coming? Any answers? Simple, right? So what you can do, you can just plug 10 to the power 6 and then divide by this factor and then whole square and then add it with 760 square and whole root over. Then that factor you need to divide with 4000 times 400. That will give you the answer. So why is it taking so much time? So let me calculate. And you also calculate, and I want to hear the answer. Yes, what is coming? Are you able to solve or not? So I got the answer. You guys must be telling me the answer. So otherwise I will not proceed. Okay. I want to hear the answer.
Okay, sir.
So what is it coming? Tell me.
So 251.5.
Correct. Around 250. Okay.
251.5.
Correct. Correct. Okay. Thank you. You did the correct solution. Okay. This is the correct answer. So you should be able to do like this. Okay. So now try the next problem. Same part, same problem. Maybe I can copy the problem also. Or this is a, I think, different problem. Same problem also you can solve for the same problem, but this is for a different problem, I can assume. So the power factor of a coil is given. Okay. The quality factor of the coil is being asked. Coil means this inductive coil. Okay. So if I give you the power factor, and quality factor means I told you already, you will do. Okay. I will not tell. And cos theta is given to you as 0.15. Now Q is being asked. So how will you solve? Easy, right? One line solution. What will you do? Think and answer. Okay. Yes, what is quality factor? How good the inductor is. So tan theta, right? Right, but the reactive part divided by the resistive part. This is the quality factor, right? So what will you do? Tan of cos inverse theta you can do. Cos inverse cos theta you can do, right? That is nothing but tan of theta. So tan of cos inverse of cos theta is given as 0.8. So what is it coming? You understood why I did this? Any one of you? I wanted what? This by this. I am already given this theta. So first I need to determine theta. But I am given cos theta. So theta is cos inverse 0.8. Now once theta is known, I need to calculate tan theta. What is tan theta? Tan of theta. Theta is cos inverse 0.8. So what is it coming? Tan of cos inverse 0.8. Yes?
Sir, 0.017.
No. I entered the power factor as 0.8, na? But power factor is given as 0.15.
6.59.
Yes. So you are blindly doing the problem, not seeing what is given. So cos theta is 0.15, right? So don't do like practice because you always know that power factor is 0.8, right? So you might take 0.8. So 0.15, okay. So yes, what is coming?
6.59.
Yes, okay. So 6.59, this is the answer. Any problem, you just tell me.
No, sir.
Because this quality factor and dissipation factor is important. So if you don't understand, tell me. We calculated both in this session. I showed you one problem where we calculated dissipation factor also, and I showed you one problem like this where we calculated the quality factor of an inductor. So always for an inductor you go with quality factor. For a capacitor you go with dissipation factor. Always you know the loss angle and all those things you are being asked. So both parameters we have calculated, and the significance of both the parameters also we have shown, and they are correlated as the inverse of one another. So you must have known this is the goodness factor, or how good your reactive element is, and this is the badness factor. This D, okay, this is a bad factor, lossy. So how lossy is your capacitor is determined by D, but 1 by D again is the good factor. So they are correlated inversely, okay. So I can write correlated inversely. Okay, any doubt in this quality factor and dissipation factor? They are both same but inverse of one another in the sense. But the philosophy is same, okay. So now, any problem in this problem? Okay, you can just let me know. Any doubts you have? Or any doubts in drawing this triangle? Yes, hello.
No,
Can you
sir.
hear me? So yes, then any doubts if you face, you can just let me know, or we can go to the next problem. Okay. So if you don't have any doubts,
Go to next problem, sir.
so can you see the problem on my screen?
Yes, sir.
So similar philosophy you need to apply, and the dissipation factor is given to you. You are being asked to calculate the quality factor. So if you have the concepts clear, you should be able to solve this problem. Okay. So I leave it up to you to solve, and I will wait for you. Okay. And you can discuss with me how to solve, how you can solve. Okay. So any discussion you want, how to solve? or you can just have a try and then we can discuss. Okay, just have a look on this problem and then you can let me know how to solve. Okay, just think about this problem. So what will be happen at the balance? At balance, anyone? If this is Z1, this is Z2, this is Z3, this is Z4, what will happen at balance? These two product will be equal to these two product. Okay.
Yes.
So now if you know this condition, because it is given to you at balance, so now what you can do? You already know that Z1, Z4 product. So theta 1 plus theta 4 equal to theta 2 plus theta 3. This you already know. Now what is theta 1 and theta 4? Both are 0, right? Since they are simple resistances. Their angles are 0 in the polar form. But theta 2 and theta 3, okay, what you can write? Tan inverse? What? Tell me. You can draw the impedance triangle. And this is R4. And then this is 1 by omega C4. And this is theta. So what you will do? What is theta? Tan inverse of 1 by R4 C4 omega, right? Plus tan inverse theta 3. Theta 3 is what? So this is theta 2, this is theta 3. Theta 3 is representing L2 R2. So omega L2 and R2. So what I can write? Omega L2 by R2. So this should boil down to 0. Okay. Because the left hand side is 0. And I have written for you the right hand side. So what I mean? Tan inverse. Now there should be a minus sign here, right? It's minus j by omega c, right? Now its absolute value should be one by omega c. But when you take the angle, it is in the fourth quadrant, right? Because this is the minus j. And then when you do it, when you take the angle theta, then you need to consider this negative sign to get the angle to be negative in the fourth quadrant. So you need to take this negative sign also. Please be careful about it. So I took the negative sign. Why I took the negative sign? Because I already know this is minus j. Okay, minus j by omega c. That's why you need to take the negative sign while calculating the angle. Because this is in the minus j plane. Minus j in complex plane. Or downwards. So the angle is negative. So when I add the two, I should take the signs also. So now what I can do? Tan inverse of minus theta. It is equal to minus tan theta, right? Agreed or not? Or I need to clarify?
Yes, sir.
So what I can write is tan inverse of 1 by R4 C4 into omega. This is equal to, I can write tan inverse omega L2 by R2. Or I can write 1 by omega R4 C4 is equal to, by eliminating the tan or taking the tan, I can write this. Now you already know what? You already know the dissipation factor. So what is the dissipation factor? Can anybody tell me? It is a badness factor. So what should come in the Y? the lossy term or the resistance of this, and always should be in series. Okay, if it not, then you need to convert to series form, because the dissipation happens due to the current flowing through the series path, and the equivalent R or the dissipation factor you need to take. So this is the R, and this C is 1 by omega C4R4. So what angle I want? This angle, delta. So what is it? Tan delta. So this is R4 sorry, this should be the yes, it is correct. So what it should be? R4 by 1 by omega C4. So it is omega R4 C4. So this is given in the problem to be 0.16. And you already have this condition from balance. So can you determine the quality factor Q from these two conditions? What is quality factor Q? It is the goodness factor. So what should come in the Y of the angle? The reactive or storing part. So it is omega L2 and this is R2. So tan theta is equal to Q and this is equal to omega L2 by R2. So I need omega L2 by R2 value. This value I need. And I already have 1 by omega R4 C4. Why? Because I already have the dissipation factor. So dissipation factor omega R4 C4 I already have 0.16. So Q is nothing but this is Q, okay? Omega L2 by R2. From balance condition I know that omega L2 by R2 is equal to 1 by omega R4 C4. So omega L2 by R2 is Q and is equal to 1 by omega R4 C4. This is 1.16. This is D, right? And what is the Q? Coming 100 by 16. Okay. So what is it coming? $6.25, right?
Yes, sir, 6.25.
Yes, it is correct. So this is
Sir,
the problem
direct
you need to. Yes. Tell me.
डायरेक्ट भी तो निकाल सकते थे ना, जैसे क्यू फैक्टर निकालने को बोला है तो मतलब 1/d करके.
हाँ 1/d करके निकाल सकते थे, लेकिन 1/d आपका क्या होगा आपको पता नहीं था कि R2 क्या है उसका. आपको तो क्या पूछा गया है? क्वालिटी फैक्टर ऑफ L2 R2 पूछा गया है. आप 1/d करेंगे तो क्या निकलेगा? किसका क्वालिटी फैक्टर निकलेगा? उसका निकलेगा जिसका
Yes.
D है. मेरे को चाहिए दूसरे का D और दूसरे का Q. तो आपको ये नहीं पता होगा तब कैसे कर लेते? There was no possibility. You did not know the value of L2 and R2. So how would you have calculated the quality factor without this condition? So the balance
Yes.
condition will give you this information. Okay.
Okay, sir.
So now you need to calculate. Okay. So now you solve the next problem. Another problem I will give you since we have some time. Let me give you one more problem. Okay. So solve a simple problem I will give you. Now, if I give you the information that omega is 4000 radian per second, okay? So can you determine the value of R1? Yes.
Yes, sir.
And also determine the value of R2. So this is the question. So R3, R4 are variable, but we know that the balance condition is happening at these values. So knowing these values, you need to calculate R1 and R2 for the balance at omega equal to 4000 radian per second. This is also given. Only you need to calculate from the balance condition R1 and R2. So try this. So try for a minute. So we can determine using bridge balance condition. So simple, right? But you need to calculate both R1 and R2 and tell me. So it is given balance at 4000 radian per second for given values. Just tell me what are the values coming. Just apply the condition of balance. So if I consider this total branch impedance as Z1 and this total branch impedance as Z2 and this total branch impedance as Z3 and this total branch impedance as Z4, I can write Z1 by Z2 equal to Z3 by Z4, right? And what is Z1 by Z2? Yes, R1 plus or R1 minus J by omega C1 and Z2 is R2 into minus J by omega C2 and divided by, so I multiply with it, R2 minus J omega C2. So this is product, right? Parallel, right? And Z3 by Z4 is coming as 2 by 1. So if I take it to the other side, R1 minus J by omega C1 multiplied with R2 minus J by omega C2 is coming as 2 times R2 omega by C2. Sorry, omega will come here, right? With a minus J sign, right? Is it correct? Okay. And C1 and C2 both are equal, I know. But still I need to derive. So R1, R2, okay? And plus I can take J square. So it is minus 1 by omega square C1, C2. This is equal to 0 because the right hand side is having no real part. So I know R1, R2 is 1 by omega square C1, C2. Now C1, C2 I know, omega square I know, R1, R2 I can calculate, right? And from another, so this is from real balance, real term balance, right? And then from imaginary terms, comparing them, I can get minus J R2 by omega C1 minus J R1 by omega C2 should be equal to minus 2R2 by omega C2. J you can remove because we are comparing imaginary terms only. So again, minus sign you can cancel. So what you are left with is, since you already know that omega C1 is equal to omega C2, I can also cancel omega C2. And then you have R1 plus R2 from this, you have 2R2. So what you can infer? If R1 plus R2 is same as 2R2, then R1 is equal to R2, right? But if R1, R2 is equal to 1 by omega square C1, C2, and R1 and R2 are same, then you can write R1 equal to R2 equal to root over 1 by omega square C1, C2. And from here you can get same value of R1 and R2. So calculate what is the value of R1 and R2. You just need to do 1 by omega square C1, C2 whole root over. So what is it coming? Calculate. Yes. Yes, please calculate. Now it is easy, right? C1, C2 value is 0.1. You just plug it in, omega value is 4000. 0.1 microfarad. What is the value coming?
2500.
So 2.5K, right?
Yes, sir.
So let me check once. Yes, it is correct. R1 and R2 are same and it is 2500. Okay. This is the answer. So it is correct. Okay. So another problem I want to give you as a homework. Try to determine quality factor of these two. So quality factor of, or maybe you calculate dissipation factor. Dissipation factor of Z1, dissipation factor of Z2. So this you will directly do 2 pi f R1 C1, right? For this. But for the second one, you need to convert to the series equivalent form. So series equivalent form. And then using R series and C series, you can write 2 pi f R series C series. That will give you D for the second case. D2 I can write. Okay, so you try it. You just convert this parallel form to series form, and then you take those series form reactance and resistance values, and then 2 pi f into R2C2 or R series C series. That will give you dissipation factor. Okay. So try once, and that will give you the full insight of how to calculate the quality factor and dissipation factor. And bridge balance condition remains the same. Okay. So similar problems you can try, and that will give you a edge of the solving the problems quickly. So any doubts?
No, sir.
Or any doubt you want me to clarify your concepts, I can just. But you guys are not joining regularly. All week, every week the sessions are held, but you guys are not joining every week, I see. and the strength is quite low. So for the announcement, I am trying to create a WhatsApp group so that you guys can regularly join and attend the sessions and also can ask your doubts or maybe get clarified. So I can mention my number and just now I can create a WhatsApp group for you to join, and my mail ID I can also write. So my mail ID is this. And whoever may be watching this video, because this is recorded, so I can create a WhatsApp group just now and can add you guys, and maybe whoever may be watching these recorded sessions, they can also get added. So that will help you. So just wait 1 second. So you can message in the group, right? You need not call, but message in the group, okay?
Okay.
Because there only I can solve your doubts, right? It is difficult to explain over call, but I can just.
सर ये रिकॉर्डेड वीडियो अभी लोड कर दीजिएगा ना?
हाँ, these recorded videos are available in the course portal, जहाँ से आप लेक्चर्स देखते हैं. उसके ठीक नीचे ही एक सेक्शन होता है लाइव सेशंस करके, उसमें क्लिक करेंगे, उसमें से लिंक आ जाएगा. ठीक है?
ओके सर.
Okay, so I have created the group and I will just write the group link. I will turn it into a short link. Because you guys are not attending regularly, so I need to post in the group only.
बीच बीच में क्या सब दो सब्जेक्ट का एक ही टाइम रहता है, तो उसमें थोड़ा सा प्रॉब्लम होता है सर.
नहीं, एक ही टाइम में होता है. जस्ट 1 वीक आई रिशेड्यूल्ड. एक वीक में मैं रिशेड्यूल किया था.
हाँ, ये आज का तो ठीक है सर. एक हम लोग का अभी 3 बजे से था, तो ठीक है. उसमें आज तो होना चाहिए था सेशन जो.
आज भी सेशन कौन सा था?
एनालॉग इलेक्ट्रॉनिक सर्किट का.
ओके ओके.
सर पर वीक दोनों साइमल्टेनियसली होता है, एनालॉग इलेक्ट्रॉनिक्स एंड इलेक्ट्रिकल मेजरमेंट.
Correct. So my session is every week Saturdays. And the
Saturday
timing
was
is the same. No, but I
Saturday
will
we-
continue in Saturday only, right? Because 1 week only I rescheduled, but now regularly every week you will get the sessions on Saturdays, and it is advised to attend the regular sessions, right? So session and all those. So I've created the group. It is tiny
सर आज
URL.
7 बजे से ट्राई कर रहे थे ज्वाइन करने का, लेकिन हो ही नहीं पा रहा था. माइक्रोसॉफ्ट का इशू आ रहा था, फिर 40 मिनट्स लेट हो गया मेरा.
Okay, so just I will solve your doubt. Just let me write the group. So this is measurement doubt. Okay, tinyurl.com/measurement doubt. measurement का M कैपिटल है, ठीक है, और कोई स्पेस नहीं, ठीक है, नो स्पेस. You write everything and only this is capital letters. So this is the WhatsApp group which I have created for you to join. And आपका जो doubt है वो I think maybe you may not have the link, or the link was not working or what, because every week when the session is held you get a notification in your email that today
Yes.
there is a session.
सर वो का ही लिंक में क्लिक कर रहे थे, लेकिन वो रनिंग मतलब हो ही नहीं, मतलब ये हो नहीं पा रहा था. फिर माइक्रोसॉफ्ट वगैरह दोबारा.
माइक्रोसॉफ्ट टीम्स कभी कभी अपडेट होता है, तो आपको एक बार थोड़ा पहले एक बार ज्वाइन करके देख लेना चाहिए, क्योंकि क्या होता है अपडेट आता है तो आपका बैकग्राउंड में अपडेट होता रहता है माइक्रोसॉफ्ट टीम्स, तो आपका तब डिले होता है लॉग इन करने में. तो आप एक बार थोड़ा सा पहले उसको ट्राई कर लीजिएगा, थोड़ा 10 मिनट्स पहले, और देख लीजिएगा. वंस इट इज डन यू विल नॉट फेस फर्दर प्रॉब्लम्स. ठीक है, जैसे आप अभी ज्वाइन हो गया तो नेक्स्ट वीक सिमिलरली यू कैन ज्वाइन, बट समटाइम्स इट अपडेट्स itself, Microsoft Teams. That's why the problem comes. Then you cannot help. Okay. So some time before 5 to 10 minutes you can join and check. ठीक है, तो this is the all the information so that you guys don't miss any session, because the sessions are really helpful and designed in a manner to give you a complete edge, and you should be attending to get your doubts clarified also. So these are the timings and these are my contact details, and you can join this group for maybe some help if you want. Okay, so that I can also manually add you in the sessions. I can do that. Okay. So I hope there is no more doubts. If there is doubt, you can just ask me, or else we can end the session, right?
No, sir.
Okay. So every week 7 p.m. to 9 p.m. every Saturdays. Okay, the session is held, and you will also get the notification. That I will ensure. Okay.
Thank you, sir.
Okay. Thank you. You can just, if you don't have any doubts, you can just leave and we can end the session, right? Thank you.